Okay, we're going to look at section 4.3 this go around. So this is going to be logs. And so what we've had before is we had y equals a to the x. Okay. Now then, we want to talk about inverses that happen with these. And so we know with inverses, we switch our x's and y's. And so now we need to get y back by itself. Now, the concern we have here is because it's up in the exponent, we can't divide the a off. Okay. Now, the other concern that we have is the fact that you can't do a root, okay, because y is going to be different values, so I can't take like a square root or a cube root. So one of the things that mathematicians came up with is that this is an equivalent format to this. Okay, so now then, one of the things that you need to be able to do is go back and forth between these two formats. Okay, so we're going to talk about how to do that. So we're going to talk about, first off, if you're in your exponential format, and when you're doing these, you need to make sure that you have the side that has more stuff on it on your left-hand side to make this work. Okay, so if you are going to go into log, you are going to make an L shape. Okay, so we're going to do log, and then the first thing that we hit is our base. This is subscripted, so it's written a little lower. Okay, and then you need to come back up to your regular level, and that's going to equal the last thing. Notice that this isn't equivalent to this. The only thing is the y's on the other side. That's fine. Now, if you are in log format, okay, we're going to use an E loop. Okay, so we're going to use an E here. Okay, so it's an E. And again, the first thing that we hit was an A, and then the second thing is Y, and then the last thing that we hit is X, which if you look is the same that we had up here. We just got them on different sides of the equal sign. Now, the reason that we need to have kind of the two different formats of this is there is some stuff that mathematically is nicer when it's in log. Okay, it's just easier to work with. It's nicer to work with. Okay, but our brain likes to comprehend things a little bit better when we are in this format. Okay, so we're going to take a look at a couple of these and just kind of get them worked from one way to the other. Okay, so that we can kind of see what's going on here. So if we did something like 2 cubed equals 8, and I wanted to get this into its log format, so I'll do an L. I would have log base 2, 8 equals 3. Now, we know that 2 cubed is 8. I don't know that I would automatically look at log base 2 of 8 and think, oh yeah, that's 3. I know that, okay? Now, if we had something like log base 3 of 1 over 81 equals -4, okay? If we're going to switch this one, we're going to do our little E loop. So we would have 3 to the -4 equals 1 over 81. And we certainly recall that anytime we have negative exponents, it pushes things down into the denominator. So then this would be 3 to the 4th in the denominator, which is in fact 81. Okay. So now, if we want to try and solve some equations, so we've got this. So we're going to loop this out. So we've got x cubed equals 8 over 27. You might be thinking, well, I don't know how to do this. But remember, okay, that if something is cubed, then the top is cubed and the bottom was cubed. So now I just need to think about what number cubed gives me 8, and that's going to be 2. And then what number cubed gives me 27, and that's going to be 3. So there is x right there. So now looking at another one, we've got log base 4 of x equals 5 halves. And again, we'll loop this out. So I've got 4 to the 5 halves equals x. Okay. Now, thinking about this, we know that that is going to be the square root of 4 to the 5th, okay? Now, one of the things that's going to happen is when we take the square root of 4, that's going to be 2 or negative 2. So I have 2 to the 5th is going to be x, or negative 2 to the 5th is going to be x. Now, 2 to the 5th, 2, 4, 8, 6, and 32. And this one will be negative 32. Now, one of the things that you have to know, math commandment, thou shalt not take the log of a negative number. So when this goes back into here, that's going to be taking the log of a negative, which means this can't happen, okay? So I really only get the one answer right there, okay? So thou shalt not take the log of a negative number. You also cannot take the log of 0, okay? That's also not allowed. So let's take a look at one more. And notice that they have put the x kind of in a couple of different places. In the first one, it was the base. In the second one, it was what we were taking the log of. So for this one, we're going to have log base 49 cube root of 7 equals x. And again, we'll loop this out. So we've got 49 to the x equals cube root of 7. Okay, now you may be thinking there is no way I'm going to be able to do that. Okay, first off, thinking back to our exponent stuff, a cube root is a 1/3 power. Now, in the exponential unit, okay, that we did, or the exponential section that we just did, we know that we can bring higher things down to lower bases. So this is going to be 7 squared times x equals 7 to the 1/3. The 7s can go away, so I have 2x equals 1/3. Okay, I am going to divide by 2. And that is going to be 1/6. Now, if you're wondering how I did that, 1/3 divided by 2, I am going to make that into a fraction, is now 1/3 times 1/2. Okay, just so there's no confusion over how we did that. Okay. So now, when we want to talk about a log function, a couple things that have to happen here. A's got to be positive and A can't be 1. Okay, same stuff that we've had before. But we also have x has to be positive because, again, thou shalt not take the log of a negative number and thou shalt not take the log of 0. Okay, now, if we talk about the graphs of these, they are the inverses of the exponentials. Okay, and so when we talked about exponentials, we had two formats. We had when A was greater than 1. Our graph looked like this, okay? We had that point right there at 0, 1, and we had another one at 1a, okay? We also talked about they graphed over that diagonal line, y equals x, which means the graph of this, first off, that spot is going to be over here at 1, 0 now. This graph is now going to look like this, okay? Whereas beforehand we had a horizontal asymptote, now we're going to have a vertical one. So this was our log base a to the x, and this was a to the x when a was greater than 1. Now, thinking about the other one, and again, we still had this point. This was when a was between 0 and 1, okay? And the graph kind of decreased as we went through. And again, we're going to have that diagonal line. Okay. And again, we're going to have that point 1, 0 that's going to be right here. Okay. Now, this one's a little more difficult to see because this piece down here, when it reflects, is going to come up here. Okay. And then this thing is going to arch down like this. Okay. So this is what, so this is, again, this is log base a to the x. And this one was a to the x, okay? And that is when your a value, your base value, is between 0 and 1, okay? Just so that we have these when we talk about them, okay? So now, kind of pulling, okay, some stuff back and giving us all of those graph detail pieces of information. I'm going to pull this back up here so I've got some space, okay? When we talk about our basic graph function, and again, we're going to talk about when A is greater than 1 first. Okay, so taking a look at that graph picture, we are going to have, okay, talking about a couple of key points here. And again, these points, because they're coming from the inverse, originally our key points on the exponential was 0, 1. Now we're going to see the reverse of that, which is going to be 1, 0. And instead of 1A, we're now going to have A, 1. Okay, so I'm going to put a spot out here at A and 1, and this is going to be here. And this graph arches up and it comes down. Okay, so now domain for this is going to be 0 to infinity. And guys, that was the range that we had on our exponential. The range for this thing is going to be all reals, which is the domain that we had on our exponential. So they are still working in those opposites that are going on. Okay? Now, we do have that this is increasing on the entire domain. It is continuous on its entire domain. We have a vertical asymptote at x equals 0. Okay. So these are kind of our key factors for this one. Okay. Now, dealing with the other one, okay, very, very similar to how we saw this in the exponential. If we are between 0 and 1, so here's that spot at 1, 0, and if this is A, this now comes here, this graph is going to do this, okay? So now, and again, we have that vertical asymptote right there. Domain is still 0 to infinity, range is still all reals. Instead of increasing, though, this one is decreasing, okay? And this is kind of very, very similar to what we saw on the other one. We're continuing, so we still have that vertical asymptote right there at x equals 0, or it's sitting right along the y-axis, okay? Now, one of the things, okay, that comes about from these, okay, so now I'm just thinking about how we would kind of graph a couple of key points here. If they wanted us to graph something like log base 3 of x, coming down here on my graph, I'm going to graph the point 1, 0. Okay, so 1, 0. And A, which is 3, comma 1. So I'm going to come out here to 3, 1. I'm going to arch that up and again keep it right there along that x-axis. Sorry, along the y-axis. Okay? Now then, when we get ready to actually graph these, one of the good things about logs, okay, and back when we did exponentials, I had gone in and put parentheses around like my x's to make sure that you understood that that was with the x and its opposite. When they do log graphs, if they put parentheses, they mean for them to be there. Okay? So if they put them, they're meant to be there. If they don't put them, they're not meant to be there. And then that number is just at the back of the problem. So this is with the x, so it's going to do the opposite of what we think. So this is actually going to go to the right one. Okay, so again, I'm going to go through and mark the same way that I did on my exponentials. So I've got this spot right here at 1, 0, and then 2, 1 is going to be my other spot. And again, we have the asymptote. I'm going to go ahead and start getting ready to move everything. So everything needs to go right 1. So this is going to go right 1. Right 1. And then the asymptote also needs to go right 1. So it's going to land right there. So we're going to arch up and drag down. Okay. Now, if we're going to talk about domain, the vertical is now going to help us establish our domain. So that's going to be from 1 to infinity. Range is going to be all reals. Okay. So looking at another one. Now, this is the way you will normally see this. If they're feeling generous, okay, if they're feeling generous, they're going to put a set of parentheses right here, okay? That's if they're feeling generous, but a lot of times they don't. And so if those aren't there, guys, they didn't put a set of parentheses on this. That means this is at the back. This is your up and down. So this is going to go down 1. So again, let's mark some original spots. I have got 1, 0, and I'm going to mark that with an X. And then my base is 3, 1. So I'm going to put that little mark there. And then everything needs to move down 1. So this is going to come down 1. This is also going to come down 1. The asymptote will also come down 1, which actually just stays where it was. And it's going to arch. Okay. So that's what we've got for that one. Now, let's look at another one. So now we've got log base 1/2 of x plus 2 plus 1. Okay, so now notice they put the set of parentheses in here, and we've got this. So this goes left 2, up 1. So here we go. Let's get our grid space going. So here's my spot at 1, 0. And then I'm going to be at 1/2, 1. Now I'm going to have to be kind of careful with that, okay, to make sure that I keep on all of my spots appropriately the way that I need to, okay? So we're going to make everything move left 2. So I'm going to come 1, 2. Notice that I'm maintaining kind of that halfway in between the boxes. 1, 2. So that's going to bring that here. Okay. Asymptote is going to come 1, 2. So now that's going to sit right here. So graphing wise, this is going to come down and arch that way. Okay. So you do have to be a little more careful with those bases that are between 0 and 1, just because they do have you kind of in between 2 values on a blocking, okay? Now, what we're now fixing to get into is a couple of properties, okay, of logs, okay? And so I'm going to start with a couple of the general ones, and then I'm going to pull up a couple of the ones that we're going to use here in just a second for some other examples, okay? So the first one is log base A of 1 equals 0. Now, where this comes from, if you were to E-loop this, okay, you would get A to the 0 equals 1. So what they actually did is they took the rule that we knew over here in exponential, they did an L shaper on it and brought it back into a log format, okay? Now, we also have log base A of A equals 1. And again, if you loop this out, you get A to the 1 equals A. Again, this was a rule that we knew over here. Now, one of the ways that we see this done, okay, is when we see log base A of A, we know that there is an exponent up here of 1 when they don't put something. And what actually happens here is the log base A and the A are canceling each other out, leaving us the 1 that's up here at the top end. Now, this rule can get extended if there is an X up here, that this and this will cross out, and that's going to leave just the X. Now, this rule we're going to use a little bit later on when we're doing some other solving stuff, but for right now, we just have these two, again, with that one. Now, we're going to get into some stuff where I talked about some of this stuff is easier in the log, when it's in the log format, than it is in the others. So, we're going to have that X is greater than 0 and Y is greater than 0. These are going to be things that we're taking the logs up. A, which is going to be our base, is greater than 0, and it's not 1. Okay? And then R is a real number. Okay? So R can be a real number, and that's fine. So, now, the first rule that we've got is what's called the product rule. Okay? And what the product rule says is log base A of xy equals log base A of x plus log base A of y. Now, we also have the quotient rule, which says log base A of x over y equals log base A of x minus log base A of y. And I see that fraction bar, and it reminds me kind of a subtraction symbol, so I remember that those two go together. Then we have the power rule. Now, what the power rule says is if I have log base A of x to the r, is that power can drop down right out in front and turn into multiplication. Now, with any of these, they can be worked both directions. So if I have multiplication inside of a log, that can move out to addition. If I see 2 logs being added, I can bring that back to multiplication. Same thing with the division goes to subtraction. If I see subtraction, I can bring that back. Power rules. Powers can come down out in front like we see over here, or we can push them back up into the exponent depending upon what we're looking to have happen there, okay? So, now then, the first thing that we're going to look at, okay, is what's called expanding, okay? Now, we're going to start with kind of some simple ones just for each rule on their own, and then we're going to look at it in kind of one of the bigger setups. So, if I have log base 6 of 7 times 9, I can break that open to log base 6 of 7 plus log base 6 of 9. Okay? And we leave it sitting just like that. Now, if I have log base 9 of 15 over 7, this is my quotient rule. So we've got log base 9 of 15 minus log base 9 of 7. And again, none of these kind of 6s and 7s and 6s and 9s, none of these really read as power things that we would have seen before. So log base 5, square root of 8. Now, you may be looking at that going, I can't do nothing with that. Remember, roots can be written as fraction powers. So now I can bring that 1/2 out in front, and I'll have 1/2 log base 5 of 8. Okay. So now we're gonna swing for the fences. They don't hold back anything when they do this first one. So I've got log base A of MNQ over P squared T to the 4th. Okay. Now, when we're expanding, kind of the general rule that we follow, okay, not every time, but general rule is we're going to do quotients first, then we're going to look for products, and then we're going to do powers. Okay, so that's kind of our order that we're going to look at. So we take a look and we do see a quotient. So we're going to separate that into MNQ minus log base A of P squared T to the 4th. Okay, so now products. We've got a couple of different products going on. Now over here, you can expand this into all multiplication, okay, and that's allowed. Now, so I've got M plus log N plus log Q. Now, I need to keep all of this other stuff together, okay? So log base A of P squared plus log base A of T to the 4th, okay? So I need to keep that all of this part was being subtracted, so I still show that it's all subtracted. Now, last thing is powers. Okay, so they may leave that sitting just like that. The only other option that they may do is go ahead and distribute that subtraction okay, just so that they don't have, this is kind of an either or type of thing between these last two lines. It's kind of your call, okay? But you do need to make sure that it's kind of one or the other, okay? Don't do some weird mix in between, okay? So now, let's take a look at another one. And after that one, this one's going to seem a whole lot simpler. Okay, so with this one, again, the first thing that I'm going to want to do is rewrite that as a 2/3 power. And then this is just a power rule. Okay. So now, with the last one, okay, or with this next one that we're going to do, okay, And then we're going to look at another thing that they'll have us do. We've got log base b nth root of x cubed y to the fifth over z to the m. Okay, now since this root is over all of this, okay, kind of the first thing I do is write each one of these with their fraction exponents. This is going to be x to the 3/5, 3 over n, y to the 5 over n, and z to the m over n. Okay, and again, that's because that is an nth root, so we know that's a fraction thing, and that fraction is going to apply to all of them, okay? So now I do have a quotient, so we're going to have x to the 3 over n, y to the 5 over n, minus log base b of z to the m over n. I'm going to separate these two with addition. So 5. Now notice there's only one thing after that subtraction, so I don't really need the set of parentheses. And now we're going to put our fractions out in front. Okay. Now, one other way that I've seen this done is back up here at the beginning. Okay. I have seen this done where they did log base b, and then all of this was to the 1 over n power, the big fraction thing, and they brought this 1 over n out into the front, but then they had to make sure that that stayed in front of everything when they finally got down into the bottom end. Okay, so you do need to be watchful of that if that's what you're going to do. Okay, like I said, this 1, 2, 3 order is the general order that we follow, but it is not the end all be all. Okay, now we also have to do what's called condensing. Okay, and this is kind of just the opposite, which means our order is exactly that. It's opposite. We're going to take powers back up. Then we're going to do product. So we're going to take addition and try and take it back to multiplication. And then we're going to do quotients. Okay. Now, note with this one and this one, okay, with products and quotients, okay, when you do those, you should have less log words than you did before, okay? Now, with powers, won't happen because powers is just moving them straight back up, okay? But there should be less log words, okay? Okay, so I don't have any powers because I don't have anything out in front of any of my logs, but I do have addition here. Now, guys, addition inside of the log is not one of these rules, okay? So we're looking for log plus log. So this is going to come back together. Okay, notice I went from 3 log words to 2 log words, okay? So less log words. Now, I do have subtraction, can go back to division. This is the one, this is the spot where I see a lot of times it is missed, guys. It is not log over log. It is log and then a single fraction over here, okay? This is not okay? That is not the same thing. You still have 2 log words. You didn't change what that was, okay? So don't do that. Now, the only other way that you might see this done would be if they actually distributed out the top of that and let it sit like that. Okay. So let's take a look at another one. We're going to have 2 log base 8 of m minus 3 log base 8 of n. Okay. So this time I do have powers to push back up. So this is going to be log base 8 of m squared minus log base 8 of n cubed. Okay, I don't have any addition, so I'm not going to have any products, but I do have a quotient because subtraction goes back to division. And that's going to be m squared over n cubed. Okay, and that's done. And we'll do one more that kind of has a little bit of everything in it. So we're going to have 1/2 log base b of m plus 3/2 log base b of 2n minus log base b of m squared n. Now, I'll be the first one to tell you, this does not normally happen, okay? Normally, what they would have done with this, okay? Normally, what would have been done here is this would have said something like log b, well, no, technically, this would have been 2 log b m minus log b n, okay? And so, guys, if you see subtract, you need to gather that back up and factor that negative out. Okay, and then start to deal with it. Okay, so if you see subtract, you need to factor that negative out and then start dealing with this, because you should only have one subtract when you get ready to do condensing, because you're only ever going to put one fraction into these problems when they are finished up. Okay, so now let's go ahead and do this. We're going to take the powers back up on these first two. Now, with the second one, 2n is all on the inside. So I'm going to make sure that that 2n gets a 3/2 put up in there. And then the last one, there isn't any powers that they had us or made us do. Now, I do have add back up here in the front, so we're going to bring those two together. Again, should have less log words. So we got that. And now we're going to bring that all back together. Okay. Now then, the only other way that they might do is, since these are both based in halves, okay, well, number one, if they have fraction exponents, okay, you are probably going to need to go ahead and put those back into their root forms. Okay, so you're probably going to have to do this. Now, the other thing that they might do with this one, just because those are both square roots, is do the square root of m 2n cubed over m squared n. Okay, now do be careful about what is under the root and what is not under the root, because you do want to make sure that all of that stays nice and tidy. When you do that, also be careful with that going into when you're having to type answers into like My Math Lab and stuff like that. Okay, so onward to the next topic. Okay, so if they tell us that log base 10 of 2 equals 0.3010, okay, and they want us to find log base 10 of 4, one of the things that we can do is, we know that is 2 squared. So I can bring the 2 down out in front. And then log base 10 of 2, we've got that as that. So that's going to be 0.6020. So that is the end of our section 4.3. So hopefully this will help you understand logs just a little bit